Somewhere out there, right now, there's a place where the laws of physics simply stop working. Not slow down, not bend. Stop. We're talking about black holes. And by the end of this video, you're going to understand something most people get completely wrong about them. Let's start with what a black hole actually is. A black hole isn't a hole. It's not empty space. It's the exact opposite. It's matter crushed into a space so small and so dense that gravity becomes inescapable. Picture the sun. Now imagine squeezing all of that mass, all 333,000 times the mass of Earth, down into a sphere just a few miles wide. That's roughly what happens when a massive star dies. When a star many times bigger than our sun runs out of fuel, it can no longer hold itself up against its own gravity, so it collapses, not slowly, in seconds. And if the star was massive enough, that collapse doesn't stop at a neutron star. It keeps going and going, crushing matter down to a single point. That point is called a singularity. And as far as we can tell, it has zero volume and infinite density. Here's the part most people get wrong. The black hole itself isn't the giant, swirling void you see in movies. The visible part, the dark sphere, is actually something called the event horizon. Think of the event horizon as a boundary, not an object. It's the point of no return. Cross it, and no signal, no light, no information of any kind can ever come back out. That's actually where the name comes from. Not because it's a hole, because past that horizon, light itself gets trapped, making the region appear completely black. So what would actually happen if you fell into one? For the first stretch, honestly, not much. If the black hole is large enough, you might not even notice you've crossed the event horizon. There's no wall, no flash, no boundary you can see. But then gravity starts doing something horrifying. Because you're not a single point, you have a head and feet. The gravity pulling on the part of you closer to the black hole is dramatically stronger than the gravity pulling on the part of you farther away. That difference stretches you, longer and longer, into a thin strand of matter. Scientists actually have a name for this, and yes, it's exactly what you think. They call it spaghettification. Eventually, whatever's left of you reaches the singularity, and what happens at that exact point, nobody actually knows. Because at the singularity, our understanding of physics completely breaks down. The equations just stop giving useful answers. This is one of the biggest unsolved problems in modern physics. We have two incredibly successful theories: general relativity, which explains gravity and huge scales, and quantum mechanics, which explains the very small. But at the singularity, both are required to work together, and right now, they don't. Now, here's a twist that catches almost everyone off guard. From the outside, if you watched a friend fall into a black hole, you would never actually see them cross the event horizon. As they get closer and closer to the horizon, time appears to slow down more and more from your perspective, due to gravity's effect on time itself. To you, they'd appear to freeze, frame by frame, fading redder and dimmer, forever approaching the edge but never quite reaching it. But from their perspective, they cross it in an instant, completely unaware anything unusual even happened at that boundary. Two people.
Two completely different realities, both correct. This is one of the strangest, most well-supported predictions of general relativity, and it's been confirmed indirectly through decades of observation. So how do we even know black holes are real if light can't escape them? We don't see them directly, we see their effects. Stars orbiting something invisible at incredible speeds. Gas and matter heating up to millions of degrees as it spirals in, glowing brightly right up until it crosses the horizon. And in 2019, we got something even more direct. The first actual image of a black hole's shadow, captured by linking radio telescopes across the entire planet into one Earth-sized instrument. That image wasn't a black hole itself. You can't photograph something that emits no light. What you're seeing is the glowing ring of superheated matter silhouetting the darkness at its center. Black holes range dramatically in size too. Stellar black holes formed from dying stars might be just a few miles across. But at the center of most galaxies, including our own Milky Way, there's something else entirely, a supermassive black hole, millions or even billions of times the mass of our Sun. Ours is called Sagittarius A star, and it's about 26,000 light-years away, the exact same galactic center we talked about in the last video. So somewhere at the heart of our own galaxy right now, there's an object so extreme it breaks the laws of physics as we understand them, and we still don't fully know what's inside. That's what makes black holes one of the last true frontiers of science, not because we know nothing, but because we know just enough to understand exactly how much we still don't. If mysteries like this fascinate you, this is exactly the kind of thing this channel is built around. Subscribe to the Zodiac Archive, because we're just getting started.